our next speaker comes from very famous research group of Dr. Peralt, and it's no one else than Emma Macturk, and she'll talk about the optimization of Fingermark residue using GC GC.
Hello, can you hear me? Okay, like Peter said, today I'll be talking about method optimization and also translation of that method to hydrogen gas using, analyzing fingermark residue using GCGC. So looking at what is a fingermark, fingermarks are incomplete or smudged fingerprints, and fingerprints are commonly used in suspect identification in criminal investigations based on the patterns that are found on from the ridges and whorls of your fingerprints. But if that fingerprint is incomplete, it cannot be used for that identification. But that residue, that chemical residue that comes from your fingerprints can still be useful to provide class characteristics like we just heard about, such as sex and relative age. And this is typically done using 1D GC. And there has been one published study performing this targeted analysis of 7 different compounds using GC-GC. So I am interested in performing a non-targeted analysis using GC-GC for profiling of chemical residue from fingermarks, and also translating that method using helium gas to an efficient method using using hydrogen gas, translating from the translating from the helium method to the hydrogen method. So starting off with my extraction process, fingerprints were first donated on microscope slides and then extracted using a cotton swab, and that swab was then centrifuged in a spin basket. That sample was blown down and then reconstituted to equal volumes. And then this sample was injected on a GC GC-TOFMS with a cryogenic thermal modulator, and then the data analyzed in chromatography. So I performed this method optimization looking at 6 different GC GC parameters with 3 options each, looking at different times, oven hold times, ramp rates, and secondary oven offset. And the methods I ended up choosing, you'll see in a second why, but I want you to notice a lot of them are on the higher ends of the time scale, like the 5-second modulation period and also the 1.5-second hot pulse time. And this was the first chromatogram, one of the first ones that I obtained using fingerprint residue, and I want you to notice that most of these compounds are congested on the far right of the chromatogram and also the very top of the chromatogram with some wraparound of some of the peaks. And after optimization, this chromatogram looks a lot cleaner, and this box, this red box here, denotes the same analytes that were found up here in this chromatogram. So you could see in this first method, we were missing all of these analytes that did not elute from the column and could not be identified using that first method. So using this non-targeted method, there were 4 main classes of compounds found: the sterile cholesterol and its precursor squalene, long-chain fatty acid methyl esters, fatty alcohols, and then some steroids. But what was unexpected about the non-targeted analysis was the findings of some anthropogenic compounds, including UVB blockers, octocrylene, octosalate, and avobenzone, which are found in common sunscreen products, and then also 2 moisturizer compounds, and then phthalates from plastics. So the ability to resolve these anthropogenic compounds from the endogenous fingerprint residue could be potentially useful in forensic investigations if this trace evidence is used as a forensic evidence source. And I also want to point out that there is ample peak capacity and empty space in this chromatogram for finding those unexpected compounds that wouldn't come from a clean fingerprint that we had in the lab. So my second part of the study was translating this optimized method to a method using hydrogen gas. And the first part of this methodology was to translate the one-dimensional component to hydrogen gas using the online ResTech modeler. This only does the first dimension. There's no online tool for using a translation tool for GC-GC. So I had to come up with the other GC-GC parameters. But this online tool kind of gave you 3 different translated options. The first was a hydrogen translate. This was like a 1-to-1 ratio. There was also a hydrogen speed option, which is the fastest chromatographic runtime, and then a hydrogen efficiency option, which optimized for resolution. And very positively, all of the hydrogen and gas methods were could very similarly resolve compounds compared to the original helium method. I also looked at peak shape of mainly squalene and cholesterol. Those are 2 main fingerprint compounds. And you could see some peak tailing in the hydrogen efficiency method, but the speed and translate methods were very similar to the hydrogen peak shape. And ultimately, the hydrogen translate method, that 1-to-1 method, was chosen as optimal for a fingerprint residue because it could identify the greatest number of peaks compared to the other 2 methods. So in conclusion, this non-targeted analysis of Fingermark residue allows us to probe the chemical composition of those finger marks. We can successfully resolve endogenous fingerprint compounds from exogenous anthropogenic compounds that could be useful for forensic investigations. And potential other anthropogenic compounds useful in these investigations could be gunshot residue, pepper spray, other things like that. And then there was success in translating this helium method to an optimal hydrogen gas method. And I want to say thank you to my lab. And I also put the non-targeted separations laboratory Instagram and LinkedIn QR codes on the screen.